Welcome back to the deep dive. So we've got this fascinating stack of sources in front of us. Dissolution kinetics papers, classic coffee texts, filtration studies. And our mission today feels really clear.
It is. We're going to stop guessing.
And start manipulating. We're diving into something that, well, for many of us, is a daily ritual.
We are talking about the chemistry of the cup. Because, look, the bean itself is it's just potential. You can have the best, most perfectly roasted bean in the world, but the brewing, that's the moment of truth.
That's the final variable, and it can either fulfill that potential or, let's be honest, it can just completely ruin it.
Absolutely ruin the entire experience.
Okay, so let's unpack that with a chemistry.
Mm-hmm.
We hear the term extraction all the time, but what are we actually doing when we extract?
Fundamentally, extraction is it's a chemical process. Water is your solvent, and its only job is to aggressively dissolve hundreds of flavor compounds that are trapped inside the coffee grounds.
So we're talking about sugars, acids, what else?
We're pulling out simple sugars for sweetness, of course,
Yep.
organic acids, like the famous chlorogenic acids, and then the bean's natural oils, we call them lipids, plus these things called melanoidins that are created during roasting.
So it's a molecular cocktail, basically, and we're trying to get the balance right.
It is a total balancing act. An extraction tightrope, think of it this way. You need some of those acids for the coffee's brightness, its tartness. But if you pull out too much...
It's sour, thin, that's under extraction.
Precisely. But on the other end, if you pull out too many of the heavier compounds, the coffee just becomes harsh and way too bitter.
And there's a key distinction there, right? Bitterness isn't the same as that other awful thing.
Astringency, yes. And that's a common mistake. Bitterness is a taste. It's on your tongue. Astringency is a mouthfeel.
That dry, puckering feeling.
It's exactly that, like licking a dry tea bag. That sensation comes from over-extracting specific polyphenols, and it is the signature of a truly deeply over-extracted cup. It's what we want to avoid completely.
So walking this tightrope, avoiding the sour and the astringent, it all comes down to controlling just three main variables.
That's it. 3 levers you can pull, whether you have a simple French press or, a $10,000 machine.
And those are contact time,
How long the water is touching the grounds,
water temperature,
how hot your solvent is.
and the filtration material, paper, metal, cloth.
Exactly. And what's interesting is that while we play with 2 of those a lot for hot coffee, we really try to keep one of them as constant as we possibly can.
And that's the temperature.
Water temperature.
Yeah.
We're always aiming for this pretty narrow band, 90 to 96 degrees Celsius.
195 to 205 Fahrenheit.
Right. And there's a very specific chemical reason for that range. You need the water to be almost boiling to aggressively dissolve those complex, desirable flavors quickly.
But why not just boil it? Wouldn't hotter always be faster, always better for dissolution?
You'd think so, but that's where the chemistry turns against you. If the water is at a full rolling boil, it can actually scorch the grounds on contact.
Yeah, okay.
And when you scorch them, you pull out all those harsh, astringent compounds way too fast. The whole balance is thrown off. So you want aggressive heat, but, controlled heat.
Just shy of that full boil. That makes perfect sense. Okay, so we set our constant. Let's start pulling the other levers, starting with methods that are all about immersion.
Let's start with the French press. I mean, it is the undisputed champion of heavy body.
And the method itself is simple. It's just total immersion, all the coffee and all the water together for a fixed amount of time.
And that's where its 2 key mechanisms come into play. First, that long contact time, usually about 4 minutes. And second, the filtration material.
A coarse metal mesh screen.
And that metal screen is chemically crucial. The mesh is so much more open than paper, so it lets 2 really important things pass right into your cup.
Okay, what are they?
First, the really fine coffee particles, we call them fines, that powdery stuff. And second, and this is the big one, the natural oils, the lipids.
And that's the magic, isn't it? Those lipids are fats. They slip through the filter, and they actually emulsify with the water.
They do. And that emulsification is what gives you that signature, incredibly heavy body, that viscous mouthfeel. It literally coats your tongue in a way that paper-filtered coffee just can't.
So if you, the listener, really love that rich, thick texture, something that feels more like whole milk than skim milk, this is your method.
The French press is your fundamental choice. But there are trade-offs.
The muddy taste, that's the #1 complaint I hear.
That muddy, sometimes gritty texture is from the fines. They're too small to be filtered, and what's worse, they just keep on extracting even after you've pushed the plunger down it.
So if you let it sit, it just gets more and more bitter.
It will inevitably become bitter and dull. The extraction never truly stops.
Okay, so troubleshooting. If my French press is gritty, the fix is mechanical, not chemical, right?
100%. The biggest mistake is using a regular drip grind. You must use the coarsest, most uniform grind you can get. That minimizes the fines you create.
And what about after you plunge?
Pour it off immediately. Pour all of it into a different mug or a carafe to stop that extraction dead in its tracks.
Got it. Now let's contrast that with its chemical opposite, but still using immersion. Cold brew. This really shows how much temperature dictates everything.
It really does. Cold brew is still total immersion, but we've radically dropped the temperature. And because of that, we have to make a huge change to the contact time.
We're going from 4 minutes to, what, 12 or even 24 hours?
At least. You need that long steep because, chemically speaking, cold water is a terrible solvent for a lot of compounds.
But the key here is what it's a poor solvent for, right? It's really bad at pulling out those volatile organic acids.
That's the secret. Those chlorogenic acids that give hot coffee its sharpness and sometimes its sourness. They dissolve much, much more slowly in cold water than the sugars do.
So you end up with a cup that's naturally sweeter.
And incredibly smooth with drastically lower acidity. It's perfect if you want to maximize those, deep chocolate and caramel notes in a darker roast, but without any of the bitterness you'd get from hot water. It's all about smoothness.
So, a totally different philosophy. Okay, let's pivot from immersion and body to methods built around the exact opposite idea, clarity and precision. Let's talk percolation.
Right. Percolation, where water just flows through the grounds using gravity, is a whole different chemical game. We're talking about pour-overs, your V60s, your Chemexes.
And here, the balance shifts.
Yeah.
We're looking at a shorter, more controlled contact time, usually 2.5 to 4 minutes.
And critically, a huge change in the filtration material. We're using paper.
And that paper filter is the chemical superstar.
It absolutely is. It's incredibly effective at trapping not just the fines we talked about, but also, and this is crucial, those cocky oils, the lipids.
The very things that give the French press its body.
Exactly. So by stripping out the oils and the fines, you sacrifice that heavy, viscous body. But what you get in return is clarity.
The compounds that mask subtle flavors are gone.
They're gone, and what's left is a crystal clean, bright, and really highly defined cup of coffee.
It's like a transparent window into the bean's origin. It's why this is so good for those delicate, light-roasted single origins with, like, floral or citrus notes.
You're letting those subtle acidic flavors shine without any of the fat masking them, but that clarity demands precision. This method is not forgiving.
No, it's not. If your water temperature is a bit low or your pour is too fast,
your contact time is too short, and you will under-extract. You're right back to a sour, weak cup of coffee.
Okay, so that's my everyday problem. Let's do some pour-over troubleshooting. My cup is sour, but I know my water was in that 90 to 96 range. What did I do wrong?
You need more extraction efficiency. A sour cup means the water just didn't spend enough time in contact with the coffee to dissolve the good stuff.
So the water ran through too quickly?
Probably. So, practically speaking, you have two options. First, you can simply slow down your pour.
To increase the contact time?
Right. Give the water more time to work. If that doesn't fix it, your other option is to grind a little bit finer.
That increases the surface area and adds resistance, which also slows down the flow.
You got it. You're just pushing the extraction further along that tightrope, away from sourness.
And how does the Chemex refine this even more?
The Chemex is just a masterclass in filtration. It uses its own proprietary paper filter that's super thick and bonded. It strips out even more oils and fines than a standard V60 filter.
So it's the ultimate pursuit of clarity.
It really is. It gives you arguably the cleanest, most delicate cup possible. Plus, that big, heavy glass carafe has a thermal advantage. It holds heat better than a plastic cone, which helps keep the extraction even.
Okay, so we've covered body from immersion and oils, and clarity from percolation and paper. Now we have to go to the extreme end of the spectrum. Force, pressure.
We have to talk about espresso. This is an extreme anomaly. It's a method designed for one thing: concentration and speed. Here we're introducing about 9 bars of pressure. That's 9 times the normal atmospheric pressure, forcing hot water through a dense puck of ultra-finely ground coffee.
The variables here are just completely warped. Contact time is maybe 25 to 30 seconds.
Ultra-rapid. The grind is ultra-fine. And pressure is the new dominant force in the equation.
It's violent extraction, really.
It is. And the result is this highly viscous liquid that's maybe 10 times more concentrated than drip coffee. You're extracting a massive amount of heavy compounds very, very quickly.
Which gives you that syrupy mouthfeel and that intense taste, which can, push the limits of bitterness.
It can. And the visual sign that you got it right, the chemical proof of success, is the crema.
Ah, the crema. It's not just foam.
Absolutely not. It's a true physical emulsion of water and coffee oils, those same lipids.
Hmm.
But it's stabilized by the carbon dioxide gas that gets forcibly released under that high pressure. A good crema tells you your concentration and technique were right on the money.
But it is so easy to get wrong. Troubleshooting espresso is a nightmare. If a shot runs too fast and it tastes thin and sour, what's happening?
Your grind is too coarse. The water is just blasting through the puck without enough contact. Classic under extraction.
And if it runs too slow, like it's just dripping out, and it tastes burnt and sharp.
The grind is too fine. The water is stalling, spending way too much time in contact with the grounds, leading to extreme over-extraction. Espresso demands, millimeter-level precision on your grinder.
So last one in this category, the mocha pot. A lot of people at home think of this as stovetop espresso. Is it?
It's a great question, and the key is the pressure difference. A mocha pot uses steam pressure, not a mechanical pump, so it only generates maybe 1.5 bars of pressure.
Compared to 9 bars for a real espresso machine, that's a huge difference.
Massive. So while you get a very concentrated cup, you don't get that true syrupy mouthfeel, and you definitely don't get a stable crema.
So what's the flavor profile like?
It's much closer to a very strong, dark, oily immersion brew. The lower pressure and the fact that the steam itself can get hot enough to slightly burn the grounds. It gives you a bold, heavy, very classic Italian-style cup. It's intense for sure, but it's not true espresso.
This has been a complete tour of the chemical possibilities. So to bring it all home, the overarching takeaway here is that your brewing method is really, it's a philosophical choice.
It's a choice about which characteristics you want to prioritize in your coffee.
Yes.
We've given you the chemical rules.
So if you want body, oiliness, and richness,
You have to choose a French press. Coarse grind, metal filter, 4-minute steep. That's how you get the lipids into the cup.
but if you want clarity, clean acids, and subtle complexity,
It has to be a pour-over, a medium fine grind, and a paper filter to strip those lipids out.
if you crave intensity and concentration,
You have to master espresso, ultra-fine grind, high pressure.
and if you want to get rid of almost all the acidity for maximum sweetness.
You commit. You start that 24-hour cold brew steep, and you leave the harsh acids behind.
So the final thought here is about putting this knowledge into practice.
It is. The most valuable thing you can do now is to run your own experiment. Go buy a single, high-quality, lightly roasted bean, just one bag, and then brew it using two drastically different methods we just talked about, say a French press and a pour-over, and taste them side by side.
So you can taste what happens when you just manipulate the contact time in the filter.
Exactly. You will taste chemical profiles, flavors, and textures you never knew existed in that single bean. And that is how you truly discover your perfect cup.